All right. So one of the things that we talked about, so the notes last night were just talking about speed. It was just talking about speed. So I've already erased all this stuff, but we talked about 2 different types of speed. We talked about if you're not moving, you don't have any speed. So kind of stuff we already knew. We talked about if you have constant speed, then it just means your speed's not changing. And that's like if your car is on cruise control. And then we talked about instantaneous speed versus average speed. And average speed is just saying like we said, like if I drive from here to North Carolina, I would say at the end, I'd be like, oh, on average, I went this fast. But it doesn't mean like the whole time I was going 80, right? I might have went 75, 85, 78, 79, 81, that kind of thing. And then when we talked about calculating speed, we said this formula was S is equal to D over T. And S was speed. And then Aurelia, what was D? Do you remember? Yeah, whoever. Yes, distance. And then what was T, guys?
Time.
Time, very nice. All right, so the biggest thing, so this is the part that I did not put in the notes, and you can either snap a picture of the screen or I'm gonna send it out. So if you wanna fill it in later, you can. But this is exactly, I didn't write this, but this is exactly how I solved the problems, okay? So we tried to figure out what we were looking for. We used a formula. We wrote down the formula. We filled in the stuff we did know. Then we plugged stuff back in and we solved for it. That's it. So the biggest thing that I want us to focus on that I think people mess up on is making sure we have the correct units. Okay. So if we're talking about time, we're usually okay with time. Like somebody give me a unit of time. Any type of unit.
Seconds.
Seconds.
Minute.
Minute.
Hour.
Hours. Days. Weeks.
Months. Years.
Yeah.
Minutes.
Exactly.
Decades. Centuries.
Exactly. So all of those are units of time. Okay. And then distance, we could use miles. We could say meters, feet, inches, kilometers, yep, all that stuff. So when we're talking about speed, since we're dividing distance by time, your unit for speed will always be like whatever unit of, I'm sorry, in case you were still writing, whatever unit of distance you have divided by whatever unit of time you have. So like for instance, when we did this problem right here, and it was like the cat walked the distance of 3 meters. This was my, let me color code it because I don't want to mess it up. This was my distance, 3 meters. And then 30 seconds was my time. Okay. So when I divide that, I don't know what a meter divided by a second is. So when I came over here and I had meters divided by seconds, I just left it exactly as that. So when I got my answer, it was just meters divided by seconds, okay? All right, so what I wanna do is like 1 or 2 practice problems, and then you guys had, oh, actually I wanted to talk about something else, but we'll do it in just a second. Let me see. I wanna do 1 or 2 practice problems, and then hopefully, we can talk some more about distance and displacement again, and something called scalar and vector. I'm gonna actually, and then we could just work on a quiz, which is like, it's literally like 10 questions. I think you'll be able to finish it during class, okay? All right, so I'm going to stop sharing for a second. Stop here, and then I'm gonna share my screen over here. Look, I figured out how to put my classroom up. So now, when you look at it, so now, like as soon as you log in, you can see the classroom right here. I added an extra laptop, so let me show you what it looks like. And again, you don't have to use this. Like everything is still right here, but really the classroom is kind of like shortcut. So if I click this, okay, this is whatever we're doing today, which I've also listed on the board. So we did that. So we already did the guided notes, distance and displacement, speed calculations, and then homework is anything unfinished. So this computer that says homework, this is going to be like legit what's due. And then right here will be the video notes for the next class. So I haven't updated this computer yet, but we will. So like today, I want to talk about, let's look at this video really quick. So we're going to go through like these two folders. We really kind of already did this. So I wanted to give you two more definitions. And you can either write these down now or you can write them down later. So this video says, we're going to watch this video. I want you to tell me what you notice about what's changing. All right, give me 1 second. Somebody wrote in the chat, but I can't see it. Hold on. I know somebody wrote in the chat, but I can't see it. Chat. Oh, yes, my fish is moving. All right, so here we go. So there's these 4 little columns right here. All right, so I want you to look at this card going around. I'm gonna let it play a couple times. I want you to look at these 4 columns and see what you notice. There's no sound, it's just kind of going around. All right, what are you realizing? Anybody?
The speed is constant.
Okay, speed is constant, which makes very nice. And if the speed is constant, basically, anybody want to tell me what does that mean in terms of distance and time?
It's gonna stay the same.
Yeah, it's gonna stay the same, right? So the distance isn't changing. And then the time, obviously, it takes for him to go around the track isn't changing either. So that's why his speed is constant. Then we have this word velocity we haven't talked about, but this one's also not changing. All right, what about distance and displacement? What do you notice?
Displacement is barely moving.
Okay, displacement is very moving. So let's think about what we said displacement was. Why do you think displacement goes up and then starts to go back down? What was displacement? Anybody remember what the definition was for that or kind of what it meant?
Like you're going back from the beginning to back to where you were.
Exactly.
Kind of, yeah.
Okay, and then I see that, Jessica, did you mean distance? Yes, distance is increasing. Very nice. All right, so the displacement is going back down because eventually you get exactly back to where you started. So if you notice, he starts right here. All right, he's going up, displacement's going up. Now it's starting to go back down because eventually he's getting right back to where he started, okay? But the distance just continually goes up because even though he ends up back where he started, he's going around, you're increasing in distance. So that's the big difference between distance and displacement. So let's watch this really short video. I wanted to introduce, I was gonna give you guys this as video notes, but I think we're gonna have time to do it in here and you still have time to do your quiz. So let's talk about scalar versus vector. All right, so the definitions we're gonna talk about is scalar and vector. If you wanna write down those two, I'll give you, the definitions are gonna be in the video, but I'll also give them to you. So if you just write those two down, scalar, S-C-A-L-A-R, and some people spell it with an E, and then vector, and then we'll do those definitions in just a second. But we'll watch this video. This video is like 3 minutes. Because I forgot there's questions about this on the Kahoot, if we can get to it. So scalar and vector. All right, I'm gonna go ahead and start the video, increase the volume.
Assume you're standing at this point. Now, if your friend tells you there is a treasure pot 50 kilometers away from home, how long will you take to find it? Which direction will you go? It could be here, or maybe here. It is hard to know where exactly it is. You are only provided the distance, which is one-dimensional information. One-dimensional information like this is called a scalar quantity. Your question to him would be, which direction from home? When you are told that it's 50 kilometers in the northeast direction, you have the precise information of the location. This now becomes two-dimensional information, distance and direction. The treasure pot is over here. Two-dimensional information like this is called a vector quantity. Scalar quantities are one-dimensional and vector quantities are two-dimensional.
Okay, let's pause there for a second. So let's get that down. So basically, she was like, hey, you have this pot of gold and it's 50 kilometers. We know kilometers are a measure of distance, or a measure of distance. It says 50 kilometers away. Or even if I said, hey guys, I need you to go pick me up something from this town. It's only 25 miles away. You're gonna be like, okay, is it 25 miles north, south, east, west, whatever. So that's the big difference between distance and displacement. So let's write this. Let's write, all right, so I'll write it down too. So I'm gonna stop sharing for a second so you can see it on here. All right. I'm learning to switching. All right, so I'm just writing it anywhere right here. I'll write it off to the side. All right, so when we're talking about, you had, oops, that's a highlighter. You had scalar and you had vector. All right, so which one so distance, okay, distance is scalar, okay. It is one dimensional. We're just gonna put 1D, okay? And this one only tells you distance, okay? So it only tells you like a length. Vector is displacement, okay? This one is two-dimensional and it's distance plus direction, okay? And sometimes instead of saying distance, you'll hear us say the word magnitude. In other words, okay, in other words, one is just a number, like 55 miles, okay? The other one is a number plus direction, number plus direction. So 55 miles east or 55 miles west, okay? So vector, you have direction. Scalar, no direction. That's really the big deal, the big difference, okay? So if you have a vector, it is also telling you a direction. If you have a vector, this is the key right here. Vectors give you the direction. Okay, scalars do not. Scalars are just numbers. Okay, so direction is the big difference. Everybody got that down? Okay, so let's go back to, I'm gonna stop sharing. And let's go back to this one, finish up this video, and then we'll go to the quiz.
Speed is a very good example of what we call in physics a scalar quantity, indicating only magnitude, but not specifying any direction.
Okay, remember I said magnitude, oh, sorry. Why you guys didn't tell me I wasn't sharing? All right, so remember I said magnitude, that just means number, okay? That's all that means, all right? So speed would be 55 meters per second.
So that's what scalar quantities are. Only magnitude, but no direction. In the case of velocity, however, the direction is stated, and that's why it is referred to as the vector quantity. A vector quantity involves not just the magnitude, but also the direction.
Right, so I'm gonna screenshot this. You can write under scalar, you could also write speed. Okay, wherever you got your scalar definition, you can write speed. And then wherever you have your vector definition, you could write velocity. I'm gonna take a screenshot of this And I'm going to put it in your Schoology. I'm going to save that. Okay. All right. And it's kind of good because you can remember that velocity starts with a V, like vector. So velocities, we're going to cover that next week. I just want to make sure you kind of understand this.
When you add directional information to speed, it becomes a vector quantity called velocity. The additional information makes it more specific. Temperature change, for example, is one-dimensional quantity. But when we specify rising or falling temperature, it is two-dimensional. If someone says that the temperature has changed by 2 degrees, we won't really know if it has increased or decreased. We will look at various scalar and vector quantities in the next few tutorials and for as long as we study physics. Speed, velocity, distance, displacement, mass, weight, force, acceleration. The more we look at these, the clearer this concept will become.
Right. So great. So next week we'll be talking about velocity. It's literally the same thing as speed, except for it has a direction. Okay. I was going 55 miles per hour. That was my speed. I was going 55 miles per hour south. That's my velocity. Okay. All right. Any questions about that? I really just kind of wanted you to understand the difference between scalar and vectors, because that is on the Kahoot, and we'll do the Kahoot either today or tomorrow. All right. So I wanted to make sure that we understand how to do those. Where did I put those questions? All right, I wanted to make sure we understood how to do these speed problems. So we're gonna do like 1 or 2 of these. I'm just gonna do them on my sheet of paper, and then I'm gonna put you in your breakout rooms. So did I stop sharing already? Okay, good. All right, so you don't have this worksheet, but I just wanna make sure you can at least do the problem with me. All right, so we'll do a speed one first. Let's actually talk through it. Okay, so this says if a car, so they wrote our formula right here. This is speed. Okay. All right, so it says if a car travels 400 meters in 20 seconds, how fast is it going to go? Now, I really want you to work past just, if you have a calculator, you might need this. If not, I had a calculator. Work past just doing the math in your head. So let's make sure, I know some of these are easier than others, but let's make sure we go through the steps. What would be the first thing you should do? Somebody tell me. If I'm solving for this.
You should fill out your variables.
Very nice. Fill out my variables. And I'm going to color code mine so you guys can see it. You don't have to do that, but I just want you to see the difference. All right, so I'm going to write this again. S is equal to D over T. And then I really said fill out my variables. So S is equal to, D is equal to, T is equal to, okay? And we know that like with this one, it's not that hard, but when we start solving for distance or time, I just want us to go ahead and have the right mindset on how to do it. All right, so do we know what S is? Technically, not after we solved. No, okay.
20.
All right, so what is the distance? Which one of these is distance?
Neither. 400. Wait, distance?
400 meters.
Exactly, the one that ends in meters. So 400 meters is here. And then the 20 seconds must be what?
Time.
Time, 20 seconds. All right, so the only one we don't know is this one. We still don't know what S is. All right, so now I'm gonna plug everything back in. I still have S because I didn't know what that was. I now have D, which was 400. And I have T. This was 400 M. And then I also have T, which was 20 S. Great, so now I'm just dividing. All right, so I'll do it on my calculator. I got 400 divided by 20. I got 20. Is that what you guys got? All right, So again, I don't know what a meter divided by a second is. So I'm just going to leave it as it is. So this is S is equal to 20 meters per second. Okay. So usually the ones where you're solving for speed are pretty easy, as long as you keep up which one is distance and which one is time. So I'm not even going to do another one of these. Let's go ahead and go to the ones where it's like solving for distance or solving for time. All right, so let's go down. Okay. I don't want you to try to memorize all those different ways to set it up. So let's just keep it as S is equal to D over T, okay? And then I really already said we got to fill in our variables, D and T. All right, so this says, how much time will it take for a bug to travel 5 meters across the floor if it is traveling at 1 meter per second? All right, Lori, tell me something you want me to fill in and where. You got
The speed.
okay, you got the speed. Okay, and which one is the speed? You're right. I do.
One.
Yes, exactly. And I know this is the speed because it says meters per second. That's a distance per time. All right, so Gloria said this is 1 meter per second. All right, and then what else can I fill in? Anybody can tell me.
Distance is 5 meters.
5 meters is the distance. Very nice. All right, 5 meters. So on this one, we don't have time. We don't know what time is. All right, I'm gonna fill everything back in. So I do have S. So this is, oops, wrong color. 1 meter per second. And I do have D. This is 5 meters. And I don't have T. So this is why I like for us to set it up, because now it's like, do I multiply? Do I divide? And I can tell you when you get ready to take the quiz, I multiply and divide it for all the multiple choice. So if you see it, don't assume it's just right unless you worked it out, okay? All right, so the easiest thing to do, I'm gonna show you a shortcut in a second, but the easiest thing to do is to cross multiply. So we can pretend that this 1 meter per second, we can make this look like a fraction as well. And we can just say, oops, sorry. We can say that this is over 1, okay? Because any number, any big number is the same thing. 1 divided by 1 is 1. 6 divided by 1 is still 6. So now I'm going to cross multiply. I'm going to multiply these two numbers and these two numbers. What's 5 times 1?
5.
5. And then 1 times T is equal to T. That's all I know, right? So it looks like T is equal to 5. Now T was a time. So what do you think is the unit for this? 5 what?
Seconds.
It is seconds, right? Because we had meters right here. Oops. We had meters right here, and we had meters per second right here. So if those meters cancel out, the only thing we have is seconds. Okay, so this is 5 seconds. Now let me show you another way to do this. This is my little shortcut, okay? Tell me if this is true. 4 is equal to 8 divided by 2. Is that true?
Yes.
Yes. All right. So look, when we did this earlier, okay, so we said we had the speed was equal to 1. Okay, that was 1 meter per second. And then we had, it was equal to 5 meters over T. Okay, that's what we had earlier before I cross multiply. Everybody agree with that? Okay. This is what we were looking for, right? Okay. This is in the same spot as this 2. How would I get this 2 right here? looking at this. How would I get 2? What do I have to do?
You divided.
I had to divide this top number by the big number. So if I do the same thing over here, divide this top number by the big number, guess what I get? 5 seconds, okay? So that's my shortcut. So every time I do math problems like this, I always write 4 is equal to 8 over 2. And it doesn't matter what numbers you use, as long as this is a true statement. All right, let's do one more for the other way. And let's try to use the 4 is equal to 8 by 2 and see if that works, okay? Let's do one for solving for distance. And then I'll let you do the quiz. Okay, anybody still writing right here? Okay. All right, so scratch that out. What's my shortcut to write? Somebody tell me my shortcut for my 4 is equal to what?
8 over 2.
8 over 2. All right. So let's do our speed is equal to distance over time. All right. This one says, how far can you get away from your little brother with the squirt gun filled with paint if you travel at 3 meters per second and you have 15 seconds before he sees you? All right, so let's fill in what we got. S, D, T. Jordan, I want you to tell me one piece that I got, and Jack, I want you to tell me one piece that I got. So there's 2 numbers here. I see this one and I see this one. Jordan, you there?
Yes, ma'am.
Okay, tell me what you want me to fill in. I got these 2 highlighted yellow pieces. Tell me where you want one of them to go. And then Jack's gonna tell me where the other piece goes.
The section should go in S, and then the distance should be 3 miles.
Do that one more time. Sorry, you were breaking up.
The S should be 15 seconds, and then the D for distance should be 3 miles.
You said the S is 15 seconds? Is that what you said?
Yes, ma'am.
Okay, so 15 seconds. So S is speed. So when I say, hey, Jordan, how fast are you running? Do you tell me 15 seconds? What seconds tell you? That's a what? Is that a speed, a distance, or a time? 15 seconds.
That's the time.
Exactly, that's a time. So we're gonna put 15 seconds down here where it's time. 15 seconds. And then, Jack, are you there?
Down here.
Okay, where do you want the 3 meters per second? Do you want that at speed or distance?
Speed.
That is speed. All right, so I'm gonna put that there, 3 meters per second. All right, so now I'm gonna fill everything back in. So I got 3 meters per second. That's my speed. I'm trying to make the numbers big so you can just see what it would look like. All right, and then D, we don't know what that is. And then for T, we got 15 seconds. All right, so now, if we were looking at this up here, what are we kind of solving for? Are we solving for the 4, the 2, or the 8?
The 8.
Solving for the 8, all right? And using this box right here, how would I get 8? What do I need to do? Multiply or divide what?
Multiply 4 by the denominator.
Right, so I'm multiplying the whole number by the denominator. So down here, I could do the same thing to get that top number because this is the same piece that's missing. So 15 times 3 is 45. So D is equal to 45. This is a distance. So what's our unit gonna be?
Meters.
Meters, very good. Look, this seconds right here in the bottom cancels out with the seconds right here. So the only thing left is this meters. So this is 45 meters. Now let me just do it the way when I cross multiply it, just so people can, just in case people like the cross multiplying, all right? So I had 3 is equal to D over 15. All right, and I'm going to pretend this 3 is over a 1 because it's the same thing. And then when I cross multiply these two, D times 1 is just equal to D. And then 3 times 15 is equal to 45. So it comes out the same way when you cross multiply. All right, any questions? All right, we got 10 minutes to do, I'm gonna throw it in the chat. 10 minutes to do your quiz. I'll throw it in the chat so you can see it. Today's lesson, I'm gonna stop sharing. All right, share screen. All right, it will not take you long. You may be able to finish, so here we go. All right, and then this is your, so I'm gonna put this link in there in the chat, and then you're just doing the one that says, are you up to speed on speed? It is very short quiz. It's a very short quiz.
My Wi-Fi is not working.